welcome to the classroom chemistry. For your kind information, you will get this channel in two languages, that is Hindi and English. The Hindi medium students will find this channel by typing classroom chemistry in Hindi alphabets, and the English medium students will find this channel by typing classroom chemistry in English alphabets. That's all about the information. Today, in continuation of the chemical bonding, I am going to explain you the orbital concept in covalent bond. In my previous video, I have explained according to the octet rule, there are two types of bonding. One is the electrovalent bond and second one is the covalent bond. Electrovalent bond or the ionic bond can be explained very well with the help of the octet rule. But the covalent bond has some limitations. I explained you the two types of the limitations. One is the incomplete octet. So here Li has only 2 electrons in the outermost orbit. Chlorine has 8, but lithium. Here beryllium has 4 electrons. So how will you explain the stability of lithium chloride or beryllium chloride? And the second limitation is the extended octet. Here in the SF6, there are 6 bonds and each bond is formed by the sharing of 2 electrons, so there are 12 electrons. So it is called as extended electron. So the question arises, how can SF6 is stable? So to overcome this difficulty, we have introduced a new concept that is called as the orbital concept. This orbital, first of the question arises that what is orbital? Orbital is a place in an atom where the maximum possibility of electron is found, called as orbital. And each orbital can acquire only 2 electrons, and according to the spin quantum number, these 2 electrons are found in opposite spins so that they are stable. So when there are 2 electrons in an orbital, that orbital will be called as stable orbital. The logic behind it, we have derived the octet rule from the behavior or the reactivity of the noble gases. All the noble gases has 8 electrons in their outermost orbit. So I have taken the example of neon. There are 8 electrons in there. So the neon can be stable as an atom form. In these 8 electrons finally located in 4 orbitals. So when these 8 electrons provides stability to the atom, then these 4 orbitals will also provide the stability to the molecule or the atom. So in this, when there are 4 orbitals fulfilled, each orbital can acquire only 2 electrons. So these 4 orbitals are fulfilled, so they are stable. In other words, we can say that when one orbital has 2 electrons in opposite spin, that is a stable orbital. That is a stable orbital. So this is the stable orbital. And again, the sharing of electron takes place in the orbital. So as I told you that the actual location of the electrons is orbital. So the sharing of the electron will take place into the orbital. and the sharing will take place in such a manner that the spin of both the electron must be opposite to each other. So this orbital is a stable orbital having the opposite spin electrons. So here the first point of this orbital concept, a stable orbital that has two electrons in the opposite spin will never take part in the sharing of the electron. This is the first point. So pause this video and write down this point, the first point of the orbital concept, that a stable orbital won't take part in the sharing of electrons. Or you can say, if there are two electrons in an orbital, that orbital won't take part in the sharing of the electrons. First thing. Second thing, the incomplete orbital, it means the orbital which has only one electron will take part in the sharing of electrons, and the number of unpaired electrons will called as the covalent. This is covalent, that covalency, the number of unshared electrons or the number of the single electrons will be called as unshared. For example, this is oxygen. The oxygen number 8, electronic configuration 1s2, 2s2, 2p4, and according to the orbital you can write here the outermost one. This is 2s, 2p2, 2px2, 2py1, 2pz1. Oxygen atom has only two orbitals which have only single electrons. These are the single electrons. So the covalency of the oxygen atom is 2. That's why when oxygen atom O2 is bonded with the double bond, this is the double bond O2, this is the oxygen, because each electron of this oxygen, one atom or two, and the second atom will share, two electrons will take part in this sharing, so that the total 4 electron will be held. So here again oxygen and oxygen is bonded with the double bond. Second example, as nitrogen 7, there are 3 electrons which are unpaired or the single electrons, so the covalency of the nitrogen is 3, and that's why nitrogen is bonded with triple bond. So here in this, I think, so the second point is that the orbital which has the single electron or unpaired electron will take part in the sharing of the electron. As I told you, the sharing of electron will take place in the orbital, and both after sharing both the electron will have the opposite spin to get the stability of the bond. So in this way, now third one. Now I am coming to the third example. Suppose this is beryllium. When I write beryllium, this is the 4 beryllium. This is 4 beryllium. 1s2 and 2s2. According to the orbital concept, this beryllium has no unpaired electron, 1s2, and these 2 electrons are also paired. So it has only these 2 electrons, 2s, this is the stable orbital. So how can you explain the formation of BeCl2? This BeCl2 shows us this that beryllium has two covalency, and this beryllium has 1 and 2. So BeCl2 1 bond and 2 bond. So how will you explain? Now the third point is the number of unpaired electron or single electron can be increased. In which manner? I am explaining you. This beryllium, in the beginning, in the starting of a chemical reaction, this beryllium has 2 electrons in the 2s2. This state is called as ground state. This I have written here, ground state. This is the ground state, and it is subjected to the chemical reaction. This beryllium atom will absorb some energy or will provide some energy for the chemical reaction. So this beryllium will absorb. That's why this one electron of 2s will be transferred to 2p, and this will be the 2px. This state is called as excited state. This state is called as excited state, as I have written here. So the energy which is absorbed by this beryllium atom to get excited, that energy called as the excitation energy or the energy of excitement. So in this way, here the number of electrons, single electrons is increased. Here the number of electrons is 0, but now this beryllium has 2 unpaired electrons, so this beryllium can have the 2 covalency. That's why it can form a covalent bond with 2 chlorines. Now the beryllium has 4 electrons. So according to the octet rule, it can't be stable. But according to the orbital concept, the 2 orbitals in the outermost orbit of the beryllium, both the orbitals have 2 electrons, and when there are 2 electrons in one orbital, that orbital is stable. So this beryllium is also stable. Again, now we come to the boron 5b, 1s2, 2s2, 2p1. So boron has only 1 unpaired electron. So the compound, so the valency, so the compound, the covalency of the boron should be 1, and the compound of the boron should be Bf. But there is no any evidence of Bf. Only we have a compound that is Bf3. Bf3. It is the compound Bf3. You will find Bf3. So there is no evidence of the Bs. Boron fluoride is not formed in this condition. So you will find Bf3. So explain the formation of Bf3. Come to the structure 5D, 1s2, 2s2, 2p1. This only p1. Here 2s2, 2p1. This is the ground state. When boron absorbs some energy, it will get excited. So this 1 electron, this 2s1 electron will transfer to the py orbital. So there will be 3 unpaired electrons. That's why the boron, the covalency of the boron is 3. In this way, so boron trifluoride is formed. Again, the octet for the form. So boron has only 6 electrons in the, but these 6 electrons are found in 3 orbitals, and 3 orbitals, each orbital has 2 electrons. So when there are two electrons in an orbital, that is stable. So all the three orbitals are stable. Like I have told you, there are the four orbitals. So here are three orbitals are stable. So in this way, you can explain the formation of or the stability of the lithium chloride, beryllium chloride, or the BF3 or any other compound which has the incomplete octet. Lastly, I am going to explain you the PCl5. So here the PCl5, how will you find the PCl5? PCl, the atomic number of phosphorus is 15. So the 15 atomic number, this is phosphorus, 1s2. So you can write here 1s2, 2s2, 2p6, 3s2 and 3p3. So I think 2, 8 and this is 5. These are the p. So here you can write here in this way. This is the 1s2, 2s3 and this one. This is. So here this is 3s, these are the 3p and these are the 3d. So here in the ground state it has 2 3s2 and 3p1. These are the. So in phosphorus you find that there are three electrons which are found as the single electron or unpaired electron. So phosphorus has three covalency like PS3. This is the again. So when PS3, phosphine comes to the stability of phosphine, so you can explain that there are three electrons. So the covalency of the phosphorus is 3. So the phosphorus can exist. So this is PS3. But how will you show the PCl5? Now again, this is the ground state. And when the excited state will acquire, this one electron will transfer to the D. This is D. So one electron is here. So again you will find here 5 electron, 2, 3, 4 and this is the 1, 2, 3 and 4 and this is D. This is D. So this 3s electron will be transferred to the D and again you will find there are 5 unpaired electrons. In this way PCl5 can be formed the stability. And there are 5 orbitals which are fulfilled, which all the 5 orbitals when shared with the chlorine electron, they will here the by sharing of the electron each chlorine, each orbital will have the double bonds. That's why this PCl is stable. In the same manner, the sulfur, when you will write here sulfur 3s2, 3p4. So the P, here P4, P is this is the electronic configuration of P. This is C and this is P2, PX2, 1 and 1. Both the electron will acquire this place. So there will be 6 electrons in this sulfur hexafluoride. And in this way, on the basis of the orbital concept, you can explain the stability of the compounds which have incomplete octet or the compounds which have the extended octet. That's all for today. I think that you have understood about the. Lastly, I am going to repeat it. First point, the orbital they acquires only 2 electrons. When there are 2 electrons in an orbital, that orbital won't take part in the covalent bonding. Second one, only the orbital which has single electron will take part in the sharing in such a manner that the spin of the both electrons, shared electron must be opposite, and the number of unpaired electrons tells us the covalency of that atom. And the fourth point is that the number of unpaired electrons can be increased by, as this concept, ground state and excited state, and this all about the orbital concept of the covalent bond. With the help of this, we can get over these difficulties, these limitations. That's all for today. Thank you very much. If you want to like it, if you want to share it, please share it and like it. Thank you very much.